Alright, so if you have pictures like this, right? Let's just do this, and remember outside the dotted, the dashed circle is the rest of the non-projection. Inside, say just the strand. Nothing else is in, say, this region I'm looking at. All it can look very distorted, as in some of the examples in the book in the last class. You can do this move that inside this region, you now added a loop like that, or you could go the other way, you could remove a loop. This is what a type 1 move. Type 2 move. Right, inside you have 2 strands, and you can sort of push one over the other one. Doesn't matter which one goes over which one, right? So it's still a type 2 move. You have something like that. And then there's a type 3 move that consists of 2 strands and a third. You can think of it as 3 strands here. I guess I'll make a comment about this, but you can think of this as, say, 2 strands with a cross and a third strand that's underneath both of them. And then what happens is you just push that third strand through the crossing, right? So you go, I guess, up here. Right. Now, if you look at the book, they'll also give you another picture where you have 2 strands crossing and a third strand that's over the other 2, and you push it through the crossing. Well, remember, we get to distort these pictures, so if you look at this picture very carefully, you'll see that this picture, if you include distortions, includes that move also, because you can think of it as, look at the configuration here. Here's one strand like this running along like this, and here's another strand running crossing over this strand. So here's 2 strands right here. And this is, say, think of this as the third strand, right? And if you move this across this crossing, so think of this as moving this strand across this crossing, you'll see that you get a picture like this. Does that seem obvious? So maybe think about it, but I guess my point here is that this move, if once you allow some planar isotopy, right, looks like you're moving this strand over these 2 crossings. So maybe I'll draw a little picture here to indicate what I'm talking about, but like you can think of it as, maybe I'll redraw that picture. Right, you can think of it as let's see, something like this. And then I move this strand across this crossing, and I get so I get something like this. Right, so this strand I push over this crossing, and I get this picture. Right, so that's the other picture that's in the book for the type 3 move. But if you stare at this picture closely, kind of move things around, you'll realize it's already illustrated by this move, where I thought of this strand underneath this crossing. So I guess the point of this picture is you can think of this bottom one as being under the other 2, or you can think of this top one as over those bottom 2.
What's that again?
So you can think of this one's underneath both of these other 2, right?
Oh, okay.
But this one's over both the other 2. So if you look at the picture carefully, you'll see that the reason he drew 2, the reason Colin drew 2 is it's a little harder to see without the distortion. You kind of think of the move maybe oftentimes as you're either moving one strand underneath in that kind of way he drew, or one over. But that when you describe the move that way, right? One set of pictures like this already describes this move. I don't know. Is that clear, or is it just kind of saying stuff?
Oh.
Saying stuff? It's unclear.
No, it's good.
Well, just look at the picture very carefully in the book and compare. Okay. All right. So I guess what I'll say Now let's go over tricoloring real quick. We didn't have time, so I'll go over the definition a little bit quicker. Now 3 chalk colors. So tricolorability. So this is the topic. This is our first real tool where we can use Reidemeister's move, or Reidemeister's theorem about the moves. Remember, it's not so obvious that these moves suffice to go between any 2 projections of the same knot, right? Like if I just create a new projection from one projection using a bunch of these moves, then it's probably obvious that you still have the same knot. But it's not obvious that if someone sort of threw at you a new projection that they claim was the same knot, then there is a sequence of such moves. And in fact, Reidemeister's move says there is, but of course there are many sequences. If you think about it, you can always do something like make the sequence longer. You could do a move and then undo it. So that seems kind of stupid, but you could do a move, undo it, do a move, undo it, and then you have now extended your sequence of moves. But there's more complicated ways to extend a sequence, which use more complicated sort of relationships. And that means there's many such sequences, and I guess it's very difficult in general to try to find the shortest sequence. So there's a sequence connecting 2 diagrams of the same knot. Like, how do you find a shortest sequence of Reidemeister moves? That's very difficult. In fact, it's very unclear, how complicated it has to be. Even if the knot's not very complicated, it's not very clear. Okay, so let's use a definition here. So often I'll write definition like this, and then like in the book, and I'll abbreviate it. Sometimes it's just DEFN. But here, the definition is a strand of a projection. Okay, so let me just draw sort of a picture here. So you see something like maybe like this. I guess if I want to keep up this convention of the dotted circle thing. So here, there's a piece of the projection that's this arc, sort of curvy line segment that goes from a crossing where it's part of the undercrossing, and it goes maybe over parts of it goes over stuff. It's part of the overcrossing, but eventually it'll get to go under something again. So this thing's called a strand of the projection, and so it's defined as a piece of projection going from undercrossing to undercrossing. So another way to think of this, I mentioned last time, is this kind of, if you really just look at a picture of a knot here, and you just look at it as an actual picture, forget it's anything to do with knots, you just look at this picture. What did I draw? Here I drew, in this example, I drew one line thingy here, then I stopped, and I drew another line thingy here, and I drew another line thingy here. There's 3 of them, right, in this case. So it's just like if you just look at the picture and like how many little segments did you draw? Those are strands. Each segment thing is a strand. So maybe it's easier just to think of it as, when you look at the picture, those are the pieces of the picture, right, that are made of these arcs. So another example perhaps here's maybe another picture. So this maybe kind of pictures sort of what often happens for a strand. But if you think about it, sometimes a strand can look like, a piece of a strand can look like this. You can start under here, and then it can come back and touch itself like this, right? So here, where's a strand? This is a strand. It's going to come back in a loop thingy here. Kind of funny, right? Here's a strand. Alright, so now here the coloring trick, which by the way I guess I should mention,